Hello. This time I want to show you a little project I'm working on and how I'm going to go about building it. This is a piece of corian, about a half-inch thick. These holes don't mean anything. They were existing. This piece was cut from a much longer piece. These 4 holes are to give me access for a bandsaw blade that I'm going to pass through. Actually, it'll help me when I'm cutting to turn around. What I'm going to do is remove this rectangular piece out of the center, and I'm going to do so without coming in from the side. I'm going to cut a bandsaw blade, thread it through, and then weld it, and then mount the whole piece and the bandsaw blade on my bandsaw, and then I can do the interior cut. And when I do that, I'll be able to then take the blade and the piece out and cut the blade to free this piece up. And then later I can actually re-weld that cut and still use the bandsaw blade for other things. How I'm going to do that, of course, is with a bandsaw blade welder. So if you're going to do this kind of work, you obviously need a welder. And the bandsaw blade, I figured I'd show you a little trick I use. See that long pipe, a piece of PVC piping? I cut that with a cap on the end such that when I run my bandsaw blade material in, when it hits against the end, it lines up with the shear. And then when I shear it off, the blade is the proper length for my bandsaw. Another trick is that this is for one of the 2 bandsaws I have. The other bandsaw takes a shorter blade, so in that pipe I drill a hole at the proper position. And when I'm going to make the shorter blade, I just put that nail in that hole, and then the blade will run up against the nail, and again it stops at the right length and I can shear it off. So once I do that, then I'm ready to weld it. Of course, I have to run it through one of those holes that I just showed you and then weld it with that piece captured on the blade. Now, another thing I wanted to point out is the welder I'm going to use. This is a Dayton 6A489, that's the model number, and you can find it online. I found this particular one, and there's a reason I'm using that word, from a seller on eBay. This welder, as you can see, is in amazing condition, particularly since it was made in 1991. I think it was purchased by someone, company or individual, I think a company, and then never actually used. It's a 220-volt input, and as the other ones out there that you can find online if you do a search for that model number, it's a 4.2 kVA welder. So it'll weld large blades up to 3/4. But unlike the ones you find, mine is unique in 2 aspects. So let's start up here. Here's the top of the front panel. You see you've got your weld pressure, nothing too special about that. And over here is your weld button. Again, the same. On every unit you can find online, this position is where the anneal button is. That's your momentary button that you use to anneal the blade. And you know you use that with ever decreasing pulse widths to heat the blade up to cherry red, and then you cool it back down slowly so that it gets that nice temper and it won't split on you or crack or what have you. It takes the brittleness out of the weld. Instead of that, this welder has a range switch. The center is off. Range 1 is 3/16 to 1/2, and range 2 is 1/2 to 3/4. So when I have it in the range 1 position, this turns it into a 1.2 kVA welder. And then, or I think it's 2.4, actually I have to double check. And then here it gives you the full range. So you have greater control when you're welding various widths of blades. It doesn't always just punch it with the full hit. But without the anneal button there, of course, how do you anneal the blade? Well, let me show you. That happens down here. You don't so much have an anneal button as you do, you have an anneal panel. Notice this, it says intensity. And as that implies, that will adjust the intensity of the anneal. You can end the annealing, but this is automated. Once you push this button, you just push it in and release it, and the machine takes over. This automatically anneals the blade, and when we get to that point, unless you've seen it before, it's really something to watch. I've never gotten a bad annealing out of this welder. This thing is unique to my awareness. In fact, I went out online to find an owner's manual for it. And of course, I type in the model number, 6A489. All kinds of examples of owner's manual. But none of them for this particular version. So I actually did call Dayton, and I got a very helpful woman in their tech department. And after explaining my situation, she put me on hold for a bit and come back and sent me a PDF for this welder. Apparently the first version of this was like this, but I don't know how many they sold before they took out the 2-range switch and made a annealing manual. So let's go and I'll weld up a blade that I'm going to use to cut this piece I just showed you, and then we'll anneal it and you'll get to see what I'm talking about. Okay, I think I'm ready to weld. I've threaded the blade through one of the holes in that piece of coriat I showed you earlier. And one thing I want to point out, if you do this kind of work, when you thread the blade through, you have to make sure the teeth are pointed in the right direction if you've marked it on one side for the cut, because otherwise you either have to flip it over and remark your cut or cut the blade again and weld it properly, and it's bothersome. And I've got weld pressure up to what I think is a reasonable amount. I'm going to put it into the lower range, which it is right now. I got you pointed straight down at the blade. I hope that you can see it. It's right here. And I've got my goggles on, so let's give it a weld and see how that part comes out. Gives a really small bead on the weld typically, and I like that. So I'm going to take this, and I'm going to get the weld pressure back down. Let these anvils open up again and clamp the blade. Now I'm going to do the annealing. I'm going to guess at the intensity. Now it'll first pulse a number of times to heat the weld, and then it starts its other process to cool it down. To make that interesting, I'm going to shut this light off. I think I'll shut the other big one off too here. Because it's kind of entertaining to watch with a lower light. Probably can't see much right now, but let's do an anneal and see how it comes out. I'm going to be very quiet so you can listen to the welder do its thing. Okay, clearly that's not hot enough. So I'm going to turn the intensity up a bit. And I don't have a great deal of practice. I've done a number of blades with this, but this intensity knob there's no real indication. Maybe I'll start making marks where the better blades work out for the width and thickness. But let's do this again. Okay, I think that was a good one. Turn the lights back on. And now I'm ready to grind that weld down and see how it comes out. But I'll test it later. But right now, I think we got a good weld, and I just want you to see how that annealing works on this welder. The automation is amazing to watch and listen to, and it certainly pulses better than I could ever do with my finger. I hope you like that, and that's it. Talk to you later.